Rakesh Kumar Aswal, Senior Lecturer, Government RC Khetan Polytechnic College, Jaipur, Civil Department. Today, students, आज मैं आपको प्रिंसिपल ऑफ सुपरपोजिशन थ्योरम बताऊंगा कि ये थ्योरम कहाँ पे यूज की जाती है और कैसे यूज की जाती है. जैसा earlier we have studied that if a body is subjected to external force, either tensile or compressive, the elongation of that body will be equal to PL upon AE. That is elongation of this body. L is the length of this body, A is the cross-sectional area, P is the external tensile load. We have studied. Here E is the modulus of elasticity. This is a constant. Now we come to the main point, principle of superposition. When any body is subjected to number of forces, earlier we studied that only P is acting, tensile force P is acting on this body. Now the number of forces are acting on a body at different parts of this body. Then how can we calculate the elongation of this body? Where we use the principle of superposition theorem. What does it mean? What this principle says? That if a body is subjected to number of tensile or compressive forces at different parts of this body, then resultant elongation of this body will be equal to algebraic sum of different parts of elongation of this body. That means we divide this body into different parts, and when we divide this body in different parts, this is called free body diagram. And this formula is applicable on elastic limit, where the Hooke's law applicable. So we take an example, a body A, B, C, D. A complete body is AD. When it is subjected to number of forces at different sections, at A 60 kilonewton, B 20 kilonewton, C 30 kilonewton, and at DD 50 kilonewton. Now we have to calculate the elongation of complete elongation, resultant elongation of this body. So we divide it into different parts. How can we divide? This principle of superposition says, how can we divide this? First of all, we take a part AB. At section AA, 60 kilonewton is acting at left side. At section BB, 20 kilonewton is acting in left side, 30 kilonewton is acting in right side, and 50 kilonewton is acting in right side. Section BB, when we calculate the total algebraic sum of load, then we take all the right side forces, algebraic sum of all the right side forces. So at B, 20 is left side, so negative 20, 30 is a right side, positive 30, and 50 is a right side, positive 50. So total is minus 20 plus 30 plus 50 comes to 60 kilonewton. So this body AB is subjected to 60 kilonewton tensile force. Now come to the free body BC. At BB, section BB, all the algebraic sum of forces of left side, that is 60 kilonewton left side, 20 kilonewton left side, so total is 80 kilonewton. At section CC, 30 kilonewton right side, 50 kilonewton right side, so both are positive, 80 kilonewton. So the free body diagram as BC is subjected to 80 kilonewton tensile force. Now the third part of the body, that is CD. At section CC, all the algebraic sum of forces of left side, that means 60 kilonewton left side, 20 kilonewton left side, but 30 kilonewton is right side, so it is negative. So net is 50 kilonewton. And at section DD, 50 kilonewton. So the portion CD of this body is subjected to 50 kilonewton tensile force. These three are free body diagrams: AB, BC and CD. Now the total or resultant elongation will be equal to algebraic sum of all these components of this body. Components AB, BC and CD. Delta AB, delta BC and delta CD. AB is tensile, BC is tensile, so positive. CD is tensile, so again positive. So total elongation will be equal to delta AB is equal to P is 60, L is 2 meter, 2 into 10 to the power 3 in mm, we have converted into mm, and 10 to the power 3, 60 is kilonewton, so we convert it into Newton, so it will be again multiplied by 10 to the power 3 divided by AE. A is the cross-sectional area. The body having the cross-sectional area 490.87, because the diameter of this body is 25 mm. So the area will be equal to 490.87, or modulus of elasticity is the value which is given us to, which is given to us 190 GPa. So 490.87, we have taken E outside of this bracket. The value is 190 into 10 to the power 3. Now plus delta BC, that is equal to 80 is the tensile force into 1 meter is the length, PL, P is the 80, L is the 1 meter, 1 into 10 to the power 3 mm. We have converted into mm. And 10 to the power 3, because 8 is kilonewton, so we have again converted into Newton. So we have multiplied by 10 to the power 3 divided by area 490.83 plus third part CD. CD is subjected to 50 kilonewton. So we take 50 into length is 3 meter. 3 into 10 to the power 3 multiplied by 10 to the power 3, because 50 is again kilonewton and 3 is in meter, so we have converted it into mm divided by 490.87, and we have taken outside capital E, that is modulus of elasticity, and we put the value of modulus of elasticity is equal to 190.10 to the power 3. So the complete value comes to us is 3.75 mm, means the resultant elongation of this body AD is equal to 3.75 under the different forces at different part of this body. This can be calculated by this principle of superposition theorem. That's all. Thank you.